This conference will now be recorded.
Right, so collections are group of objects, and they are an upgrade to an concept you already have seen in past. Okay, that is arrays. Okay, so let's see what arrays provide us, and then we can compare that with what collection provides. Okay, so when you declare array, you have to provide the size, which makes it fixed. Okay, so when you declare some array like this, you have to provide the size of this array upfront. Okay, that makes it fixed. Now, this is a drawback with respect to most of the applications. Okay, for example, if you're developing a shopping website, what would be, where would you require group of objects? What information would you like to store in a group?
Product information like price, description.
Products, customers, okay, or shopping cart. Okay, these are the information you might want to store in a group. Okay, now array is not an ideal candidate for these things. Okay, because array requires fixed size. So does all the websites that you see, Amazon, Facebook, do they have a fixed number of customers or do they vary? Yes?
Vary.
It varies. Now, in the shopping cart, do all the customer have equal amount of items in their cart, or does that vary as well?
Varies.
It varies. Okay, so array would not be an ideal candidate for situation like this. Okay, you might choose array when the size is fixed. Okay, like let's say you want to have a university enrollment program. So there the number of seats are fixed. Okay, they only allow 100 people to enroll every year. It's a fixed size, array makes sense. If you're writing a program for a movie theater, there are fixed number of seats. A flight, there are fixed number of seats. So array only makes sense to scenarios where the number of items are always fixed. But what do we do for these scenarios where the size vary from customer to customer, company to company? For this, we have what we call collections. Okay, collection is also a group of objects just like arrays, but it allows you to have a dynamic size for the group. Okay, the size of the collection group varies. It can increase or decrease. Okay, that's the first point. There is another drawback in arrays. Okay, when you declare an array and let's say you remove an item or you add a new item, okay, it creates a problem. Okay, let's say you have just two names as of now, and the array size is 3. Okay, so you have two items, John and Jane. Okay, and the total size of the array is 3. So if you print it, okay, if you print this array, it gives you John and then null and Jane. Okay, because we didn't initialize the second item, we just initialize the first one and the third one. Okay, so it will show you a null in the middle. Okay, now what if you want to insert a new name at the third position? Okay, so you want to insert another name at the third position. When you do that, you lost the previous name Jane. The previous name Jane in the third location was overwritten by Mike. Okay, you lost the third name in the list in the array from Jane to Mike. You couldn't insert that. Okay, so when it comes to editing an array, it's quite difficult. Okay, if you anytime you do an editing, you have to go through the for loop, read the items. Anytime you want to add a new name, you will lose whatever name you had previously in that location. Okay, so these are the few drawbacks. Editing becomes challenging. Okay, the size becomes challenging. So for all these reasons, we have something called collections. Okay, collection is the answer for all these problems. Okay, so let's see what are the type of collections. Okay, so these are the collection categories. Okay, these three are the collection categories. Okay, now collection provides a wide variety of programs, and each one of them have a unique feature, and they are suitable for a exact matching scenario as well. Okay, every program, now there are dozens of classes, dozens of category in collection class. Unlike array, there's only one concept in array, right? So collection has dozens of programs in its each categories, and all of them have unique features that is suitable for a perfect scenario that you might need. Okay, so let's go through one by one. What we'll do for the next 1 hour is we'll try to understand what are each of these categories. Okay, what is a list, what is a set, what is a map? We'll understand what these categories are. Then we'll understand what are the various programs, classes we have in each of these categories. We will learn how they are actually implemented. Okay, how did the JDK founders create these collection classes? How do they internally operate? Okay, we'll learn that. So that will help you to make a decision out of those dozens of collection classes, which one is the right choice given the scenario for your requirement, for your project, which one is the right choice. To understand which collection class you need to understand how these collection classes are implemented. Okay, that's the reason. Now, whatever I explain you for the next 1 hour, it is just for a concept point of view. It will help you understand how this is implemented. How is this working? How are the collection classes working? Okay, that's what I'll be explaining you. With that knowledge, you can choose whichever collection is best suitable for your project, for your requirement. Okay, so you understand the goal, right? Whatever I explained, I'm going to explain the concept, how it internally works. Okay. Arrays have fixed size. Okay, these are dynamic. Okay. How do we store items? We store items in a single value. Okay, in map, we store the values as a pair. Okay, it is something called key value pair. Okay, I'll explain you what that is. So here we store item as single items. Okay, if you have string names, then all you have in this names array is a single item, John, Jane, Mike. Okay, there is only one item. And even in list and set, you'll have single items. When it comes to map, map is more like a key value pair. Okay, so now let's think about this, right? If you want to find out student information based on their registered ID or student ID, okay, key value pair would be the right choice. Okay, you give me the student registration ID and I will give you all the information about that student. Okay, give me the student ID, I'll give you all the information of this student and so on. Okay, with the name key, what does that remind you?
Reference, memory reference.
No, forget about Java. Generally, what does a key represent?
Indexing.
To unlock or lock.
To unlock a specific locker or a specific door. Okay, it is specifically or uniquely defined. Okay, keys are unique. Okay, so imagine this. What if two students have the same ID? Won't there be a conflict? If two students have the same ID, if two people have the same social security number, what will happen? There will be a conflict, right? So keys are generally defined as a unique nature. Okay, keys are of unique nature. Keys are always distinct. Okay, values can repeat, but keys always have to be unique, because if you store all the information in this order, a key to its value, and if there are two duplicate keys like this, okay, if I ask you to give me the information of student whose ID is 2, which one will you give me? Will you give me this student or this student? There will be a problem, right? So keys are always unique, remember that. So you can uniquely identify which item you are looking for, which value you are looking for. Okay, so that's how the map operates. Map operates as a key value pair. Okay, as opposed to arrays or list or set, they are single value. Okay, they all store single values. Okay. In arrays, you're allowed to store duplicates, aren't you? Can I store John and John, 2 items?
Yes.
Yes, you can store the same duplicate values in that array, in all the 3 items. Okay, so array allows you to store duplicates, and so does list. Set is a unique. Okay, set stores only unique items. Okay, in case of map, key are unique. You cannot have duplicate in the keys. Values can be. Okay, values can duplicate, but the key will always be unique. Okay, set will only allow you to store unique, no duplicates. Okay, indexed. Does array have indexes?
Yes.
Yes. Okay, and so does list. Set doesn't have index, map doesn't have index. Okay, arrays are indexed and so does list. Set is not indexed, map is not. Okay, ordered. Ordered is when you add an item in an order, John, Jane, Mike. The items are stored in the same order, isn't it? Same sequence. If the first item is John, second item is Jane, third item is Mike, it will always remain in the same order. Okay, no matter how you print, it will always be in the same order. Okay, that's what ordered means. Okay, if you store as John, Jane, Mike in this order, when you print, you get John, Jane, Mike in the same order or the same sequence. Okay, so arrays are obviously ordered. List is also ordered. Now collection is a slightly different. Collection allows you ordered and unordered both. Okay, yes and no. Collection allows you to store information in a particular order and unordered both. We'll see what's the benefit of both. Okay, but right now remember, ordered meaning if you store items in a particular sequence, they always remain like that. Whenever you read it, you read it, you will always get the same order. Okay, sorted. So here, what would be the sorting you require? What comes to your mind when you say sorting?
Quick sort.
Alphabet.
Filter.
Alphabetical order. Okay, when you go to filter, what does it say? Sort A to Z or Z to A? You're sorting in alphabetical order, isn't it? So here, what would be the right order? Who comes first?
Jane.
Jane comes first because we have two words that start with J. The next word here starts with O and here it starts with A. And for that reason, Jane comes first. And who comes next?
John.
John. Mike starts with an M, which comes after J. So Mike goes here. If you have another item, where does this one go?
On top.
On the top. Okay, A is the first alphabet, so it goes on top. This is what we call sorting. Okay, if you have an array of integers with the numbers like this, what would be a sorting with reference to an integer array like this?
Four, 5, and 12.
This would be a sorting, right? So that's what we mean when I say sorting. Okay, so arrays are not sorted. Okay, arrays are not sorted. List is not. Set allows you a program that can do sorting. Map allows you a program that can also do sorting. Okay, so sorry, this is no, set yes, and map yes. Right? Now let's imagine why we are discussing all these duplicates, index, order, and sorted. Okay. Take one particular real world example and tell me when would you not need a duplicate? Not Java related, whatever you did on the internet so far. Have you come across anything which tries to avoid duplicates?
Passwords.
Nobody requires duplicate password.
Username. Can we?
Username, on the other hand, are not allowed as duplicate, not passwords. If you have already, if there is already a user John in the Gmail, if you're trying to register with the same name John, will it allow you?
No.
It don't. It will ask you to use a different user ID. Okay, so a situation like that might require you to consider something like a set, which allows you to store unique only, no duplicates. So if you want to store all the user IDs, would you not rather go with set, because set allows you uniqueness? Yes. That's one of the features. Now, where do you think this order might be necessary? Give me a real world example where order is important.
Prices in the shopping app.
Prices in the shopping app. Okay, maybe. Now you go to a restaurant and you place your order. Your order will be served in the first come first order basis, or they randomly just give anyone any orders?
First come first.
Right? If you're the first person to order, don't you deserve to get served first? Doesn't the restaurant have to make sure that your order is prepared first?
Yes.
Ordered. First come first serve. So if you want to store all the restaurant orders in a collection or an array, you might very well go with these things, arrays or list. Here the items are stored in order, so that will allow you to process every order in the same sequence. Okay, where do you need sorting?
On our phone book.
In your phone book. No matter how you store, how you add a new contact, it always displays as a alphabetical sorted order, isn't it? So if you're writing a program for the contacts, sorting would be the best way to go, no matter how they add new contacts. Okay, if you add a new contact, most recent one, which starts with the name N, then with arrays, it will show the N word, the N name as the very first one in your contacts. So is array the right choice for a phone contact app?
No.
No. So wouldn't you go with a set rather than array? They all are group of phone numbers. The contact app is a group of phone numbers and their names. So would you not rather go with set rather than arrays if you want to store the phone number, the phone names?
Yes.
So for every particular scenario that you might get into, you have a specific need, and there is a specific solution for that already written. You don't have to write any code for that. It's already there. It's just a matter of using it. Okay. For every scenario here, if you need a key value pair, like a student app, okay, where you store the student ID versus the student details, or a customer user ID versus customer's profile. Give me the user ID of the customer and I will give you the customer's name, contact number, email ID, their profile information, their service information. I'll give you everything. Just give me the user ID and I'll give you that customer's profile. Key value. So for every need, every requirement that you might have to implement there, you have a collection that is already ready for you. It's just a matter of choice. How do you pick them? Which one do you pick? Do you pick arrays or you pick one of the collections? Do you pick list or a set or a map? Okay, set is a unique group of set. List is an indexed collection. Okay, so remember this chart. This will allow you to make decisions when you're picking one of the group concept, arrays or collections. Okay, so do you understand these terms? Duplicate, indexed, ordered, and sorted.
Yes.
All right. So now let's go with how these collections are implemented. This is a typical array. The size of the array is already fixed. Okay, size of the array is already fixed. List has 3 categories. Okay, list has 3 categories. Array list is one of the class, vector is another, and linked list is another. Okay, so there are 3 categories in the list. So let's see each one of them. Array and vector are internally implemented like an array. Okay, array list and vector, these are the 2 classes from collection family, and they both are internally implemented like an array. Okay, okay, these are the classes in the list program, in the list category. Okay, remember this collection has 3 categories: list, set, and map. These are the 3 categories in collection: list, set, and map. Now we are learning about list. Okay, in the list program we have more classes in fact, but we'll be focusing on these 3 classes. Okay, these are the programs or the class in the list category. Okay, so we'll see how they are implemented and how it works when you add a new item. Okay, how does it make it dynamic? How does it make it easier for you to insert and delete items from a specific position? Okay, that's what we'll learn. So we have 5 names here: John, Jane, Ram, Raj. Okay, so we will see how these names are stored in a list and a set category. So let's start with here, and okay, let's assume there are 4 items. Okay, there are 4 items in the array: Andy, Mike, John, Jane. So what ArrayList does is it will create an empty array of, let's say, size 10. Okay, ArrayList, when you initialize ArrayList, it will create an empty array with size 10. Okay, there is no items, there are no values in this empty array. Okay, now when you add the first item and D, it will add this item in the 0 position. Okay, it will add the first item in the 0 position. When you add one more item, Mike, it will add this in the next available position 1. Okay, when you add John, it adds in the next available position, and then the next, and so on. Okay, so this is the thing, right? How does it make it dynamic? How does the array list make it dynamic? Okay, so let's reduce the size to simulate that. Okay, assume array list was created with 5 items, 5 empty items here. Now you go on adding one item after another. You add the first string, then this next string, and the next, and the next. When you reach the end of the array, okay, when you reach the end of the array, what collections do is they double the current existing size. Okay, now what is the current size of this array?
Five.
It's 5. So what it will do, it will double the size of the array from 5 to 10. Okay, now when you add the 6th item, it will go here. Now this is a good thing. You don't have to worry about this thing. It's all happening on the fly. You don't have to worry about anything. All you do is add an item. You add one name after another, and this, whatever is happening here, how it adds, how it grows, it's all happening on the fly. You don't have to worry about it. It's all happening without your knowledge. All you do is keep adding or keep deleting items from your array list. That's all you do. Okay, internally array list and vector, they use arrays to achieve this thing. What they do is they internally use an array to provide you this dynamic growth, insertion, and deletion. Okay, so you keep on adding like this, and what happens when you reach the end of this array?
Grow size of 5.
Not 5, you double the size. What is the current size? 10. Current size is 10, you double it to 20. So this is what I was talking about when I say the size is dynamic, not fixed. In case of array, the size is 4. What happens if I add a 5th item? What happens if I add the 5th item?
Array size increase.
For
No,
array,
it will show the exception.
Array out of bound exception.
array out of bound exception is what you get, because when you declared this array, you created just 4 items. You gave the size as 4. So when you add the 5th item, index 4, when you add the 5th item, there is no more space here. It will throw array index out of bound when it comes to arrays. However, when it comes to collection, when you reach end of the array, it doesn't throw an exception. What does it do?
It increases size then here.
It will double its current size. If the current size is 10, it becomes 20. If it is 100, it becomes 200, and so on. So this will not throw any error. If you add an item after you reach the end of the array, it will automatically double in size. You don't have to worry about that. This is how it achieves that dynamic growth. Okay, now it doesn't just grow infinitely. Okay, after a while, if you delete all these items, what will happen? You kept on increasing this array like a million size. What happens all of a sudden you delete everything and just keep 3? Aren't you wasting that other million space here? So collections doesn't just dynamically grow, it dynamically shrinks as well. Remember that. Okay, it will dynamically shrink as well. So when the capacity falls below 50%, it will shrink. Now the size of this array is 20. How many items do we have? How many values? Can anybody count this really?
3.
3.
3. So the size is 20 and you're using only 3. So you're using less than 50%. So what happens when you use less than 50%? It will dynamically shrink. It will shrink from 20 to size 10, from 10 to size 5, and so on. So collection is not about just dynamic growing, it will dynamically shrink as well to save memory. So does everyone understand how array achieves this dynamic growth and shrink?
Yes.
All right, so when you reach the end of the array, it will double your size. If you're using less than 50% of the capacity, it will shrink in size. This happens on the fly. You don't have to lift a finger. You don't have to do anything. If you're curious, if you want to add an item, this is what you do. Okay, you want an array list of string names. Okay, equals new array list. Now, do you see any size defined here when you declare a collection, array list collection?
No.
There is nothing. Okay, there is no size declared because collections are dynamic. Okay, if you want to add Andy, all you do is names.add Andy. That's all you do, and a new item gets added. Okay, if you want to add Mike, Mike. If you want to remove Andy, from developer's point of view, all you have to say is add or remove. That's all, and it will add items. It will remove items. You don't have to do anything at all. Whatever I taught you, it is just how it will internally handle your operations. Okay, it will dynamically grow, it will double the size, it will shrink the size. Everything is happening dynamically. Okay, for you, it's as simple as saying add, remove, that's all. Okay, this will be your coding, but internally, this is what it does when you exceed the capacity or when you suddenly drop the usage. Is that clear?
Yes,
Yes.
how the initial size is, defined like 5.
Mhm.
So
The
how the
initial,
initial size?
right. So if you're curious, we can just check what is the initial size. Default capacity is 10, like I said. So it starts with 10.
Okay.
Okay, it starts with 10. If you end up using all 10, it will make it to 20. Okay, it will grow as you use it. It will shrink as you drop the usage. Now, the other problem that I told you about arrays, editing. Now, if I set the value of second index to ASD, what will happen?
It will replace Mike.
The index, again, guys, why do you get confused? What does index of 2 means?
1. The position on number 1
What is index of 2?
shown.
It's not Mike. You start with 0. So if you say index 2, you're actually pointing item number 3. I have written it right here.
So sorry. Yes, you're right.
So what will happen to John? You will lose it. Okay, you will lose this value. In collection, it allows you to insert a value as well. Insert, not overwrite. In this case, in array, you overwrite an existing value. Whereas in collection, it allows you to insert a value as well. Okay, so if you have some name here, and if you want to insert Jane in this position, index number 2, so you won't lose the John value. What happens is John value is moved one level below, and Jane is added to the location 2. So when you insert in a particular index, in a particular position, you won't lose it. You basically just move everything down one line below. Okay, now arrays can have gaps in the middle. Okay, there might be null here, there might be null here. Okay, but collection array list is a consecutive block. Okay, it is a consecutive block of items. Each time you say add, it will immediately add in the next sequence. Okay, now this is the thing. You have these items in the collection. If you insert ABC here, what happens?
ASD will move down one step down.
And what about AD?
So everything will move down.
Everything will move down one level, one step below. If ASD moves to one level down, you will lose AD as well, isn't it? So AD also has to move one level down. This also one level down. This also one level down. Everyone have to move one step below to make room for the new entry. For the new entry, everything will move one step below. Okay, so at any time you won't lose any data by overwriting. And if you delete this, if you delete the ABC, okay, what will happen now? Remember, like arrays, there won't be any null items. There won't be empty position is what I'm saying. There won't be empty positions anywhere. So if you remove ABC from here, what happens?
Everything will go up.
Everything will move up by one level. Okay, so you have a consecutive block of values. You have a consistent consecutive block. There won't be any gaps. Okay, there won't be any gaps in the middle like this, like an array. Okay, if you remove an item, everything will move one step below, above. If you add an item, everything will move one step below to make room for the new item. Okay, so it shifts the position in every possible way. Okay, it shifts the position in upward direction or downward direction, both. Okay, that's how internally ArrayList is working when you insert or when you delete. All right, does that make sense? Okay. Okay, so when it comes to vector also operates like ArrayList. Okay, vector also operates like ArrayList with one key difference. Vector is synchronized. Okay, we are hearing the term synchronized quite often. So where do you generally use the term synchronize? Where do you generally use the term synchronize in your everyday life? Okay. So synchronization refers to timing.
Time.
Okay, if you're about to meet your friend, don't you both synchronize your time? I will meet you there at 5 o'clock. You can also come there at the same time. Don't we call that as synchronizing our time? Don't we coordinate our activity at the exact same time?
Yes.
That's what synchronization is. So let's see how that impacts. Okay, I'll give you a quick overview on what synchronization is and why it is necessary. Okay. Now this is an airline seating software. Okay, so you have airline bookings here. And so on. Okay. Now there are 4 customers trying to book this flight. There are 4 customers trying to book this flight. Okay. At any given time, they can only book one seat. Okay. What if there is a conflict? What will happen if 2 customers? Okay. What will happen if 2 customers try to book the same seat at the same time? Customer 1 and 2 try to book this aisle seat, one seat, at the exact same time. Don't you overbook this seat? So how do you handle this thing in a general scenario?
First come, first serve. Or first come, first get. Whoever booked it first, they're gonna get it.
Right. So what you do is you put a lock on the system. You put a lock on this seat, meaning if anyone is trying to make changes to this one item, one seat, it can be done by only one person at a time, not multiple. So if 2 people are trying to book this exact same seat, only one will gain entry. Okay. If customer 2 is already in the process of booking, customer 2 is already in the process of booking, customer 1 will be kept on hold. Customer 1 will be kept on hold until customer 2 either ends up booking this or rejecting this seat. Until this becomes back available or it is already booked, this customer is not allowed to make any changes to this seat number. That's what we call synchronize. So synchronize has one drawback. If there are 4 customers trying to book the same seat and customer 3 got access, got lock on this seat. So customer 3 is in the process of deciding, should I book it or just release it back? What is customer 1, 2, and 4 doing right now?
They're waiting in queue.
They are waiting. They are on hold. So waiting and on hold means delay. Delay means performance issue. So whenever you have a scenario like this, which requires only one program to make changes at any given time, while the other program keep on waiting, this is what we call synchronization. Until this customer decides what they want to do with this seat, the other programs have to wait. So this will lead to one major problem, that is performance issue, delay, waiting. Okay, so always remember synchronize equals to high performance or low performance.
Low performance.
Low performance. Okay, synchronize is equal to low performance, because anytime one program is trying to make some changes, the other programs will have to wait, because we need this consistency. We don't want to overbook the same seat by two other customers. So if someone has already selected that seat and they are confirming their order, the other person will be shown as on hold. So they can't do anything. They'll kept on hold. So that will lead to another problem called low performance. But at some point, at some situations, even though the performance is low, don't you really need that to ensure this consistency? For the data integrity, we don't want the same seat to be booked by two people. For data consistency, integrity, we need synchronization in some softwares, but that comes at a cost, and the cost is what's the cost?
Time.
Time, performance. It's a low performance. So does everyone understand what a synchronization is?
Yes.
Now here, vector is synchronized, meaning imagine if this seat example that I gave you, all the seats, imagine if this is stored as a vector. If two customers are trying to book any of the items in this collection vector, they cannot do at the same time. Okay, thereby guaranteeing the consistency. ArrayList, on the other hand, if I choose this airline booking software to use ArrayList, this is not synchronized. So what will happen is performance is good because no one will be on hold. But what is the drawback? With ArrayList, what is the drawback in this scenario?
Low performance.
No, it will be, I think, conflict like.
Yeah, conflict. Anyone can get anything. Any
Okay,
seat.
two customers might end up booking the same seat with ArrayList because it is not synchronized. Okay, synchronization is only allowed, is provided by vector. So if you want that consistency, it has to be vector. But if the same example, in the same scenario, if you do not use vector, performance will be high, but it cannot guarantee that there will be duplicates. Okay, it cannot guarantee that there will be overbooking. So vector comes at a cost. That is low performance, but it is needed in certain situations. Okay, vector has the same features of an array list. It has the same feature that I explained you. You have indexed item. If you reach the maximum size, it will double. It will shrink dynamically. If you insert an item in a position, everything moves down by one level. If you delete an item, everything moves up by one level. All the features are same. Okay, with one exception. Whatever you do, insertion, deletion, adding, removing, whatever you do, they are all synchronized. So every time you try to insert in a position or delete from a position, or just plain and simple insert delete, it will be slower as compared to ArrayList because it is synchronized. Synchronization comes at a cost, low performance, but it allows you to have that data integrity. Okay, ArrayList, whatever I explained you how ArrayList works, vector also works similarly, with one exception. All that activity will be synchronized. So no two people can make changes to this object at the exact same time. Okay, to ensure consistency. All right, so any questions on array list and vector?
No, sir.
All right. Now, linked list is another program in the category list. Okay, and this is slightly different than a traditional array size. Okay, linked list is slightly different on how it is stored compared to array list and vector. Okay, so before we go there, let's see what is the drawback in these things. Okay, let's see what is the drawback in array list and vector. Now, if you imagine that there are 1 million items in this array, okay, 1 million. If I insert ABC in position 4, what will happen?
It will add another 1 million.
How will ArrayList process it?
So if it's already full, then it will add like another one. It will go one step down.
The question is the same thing. I'm going to add and it will get added. There is no doubt. When I say I'm inserting ABC in position 4, it will get added. There is no doubt in that. But I'm saying, what is the impact of adding an item in a position?
Double the size.
Sorry, what was that?
I said double the size.
Okay, you are not up to the max limit yet.
Position of other items will be changed below it.
All the items are moved one level down to make room for the new item. To make room here, you have to move everything one level down. So to adding one item in the middle, how many other items you have to move down?
Everything below that position.
Everything below that position. You have 1 million items and you're inserting in position 4. So how many did you move? 999,996. So do you see that as a problem? You have to do so many things just to insert one item. The impact is to 999,000 other items which has to move one position below. Isn't that a problem?
Yes.
The same goes for deletion. If you have to delete the item number 5, what happens now?
Thing will move up from 6.
Starting from position 6 till 1 million, all these 999,000 items are moved one level up. That's a huge task, isn't it? So is ArrayList and vector suitable for inserting in the middle?
No.
No. For that reason, we have something called linked list. Okay. For that reason, we have something called linked list. So let's see how linked list operates. Linked list internally does not utilize arrays. Okay. It has its own way of storing elements. So you have item number 0 here. Then we have item number 1, item number 2, okay, so on. We have item number 999,000 and 1 million. Okay, so this is item number 1 million, and this is item number 999,000. This is the first index. This is the second index. This is the third index, and so on. We have like 1 million items. Okay, so this is like a list with 1 million items in that. Okay, so in linked list, every item remembers who is the previous person and who is the next person. Okay, so what that means is, let's say this particular item 0 is in a position 111. This item is in position 234. These are references. Okay, these are address references. So linked list, what do you mean by link?
Connect.
Connects, joins, like a chain. So have you seen a chain? How does chain look like? Isn't every unit connected to each other on the left and the right?
Yes.
Yes.
That's how linked list works as well. In linked list, everything is connected towards its left and the right, or the previous and the next. Okay, every item in this collection knows where is the next item and where is the previous item, just like a chain. Okay, every link in the chain is linked or connected to its previous item and the next item. Okay, so let's see how it operates. The John, the first item or the first index, is in the location 111 reference. The second index is at a position, is at a reference address 234, and so on. So if this is the first item, okay, it can be scattered anywhere, doesn't matter, as long as you know everyone's position. Okay, it can be scattered anywhere. Okay, remember, array list and vector, they have a consecutive block like an array. Okay, first item, second item, third item, and so on. Okay, they are indexed and in a consecutive block. Whereas linked list is scattered, and only thing that is connecting to them or holding them together are the links. Now the first item in the link, first chain, is there anyone in the previous position when I say it is the first? If you are the first one in the rest, who is ahead of you?
No one.
No one.
What?
No one. So what does no one, nothing means in Java?
Null.
Null.
Null. Okay. Now, who is the next person in this list? This person. What is the address?
234.
234.
So as I said, every person remembers, every item in the collection remembers who is before them and who is after them. So in case of John, who do you say the address is in previous section for the second item?
111.
111. And who is next?
456 reference.
This person. For Mike, who is previous?
234 chain.
Okay, so remember this is their address, their own address. And this is what they know about their neighbors, which connects them on each side. Okay, this is the information about their previous and next neighbor in the chain, right? So for the last item in this link, what is the address of previous?
Now,
Previous.
546.
Who is on the left side of this guy? If you are the last person, who is after you?
Null.
If you are the last, there is no one after you. If you are the first, there is no one before you. That's how you realize if you're the last item or the first item. Right. So this is how linked list is set up in the memory. Every item knows who is the previous person and who is the next person in the line, in the chain. That's how connects them each other. Okay, that's how everyone is connected to each other. Okay. So here's the question. Now, in case of array list, if I want to add one item here, I literally have to move everything starting from index 1 till a million, one level below, and then make room for this new entry. Okay, that was our problem. Moving hundreds of thousands of items just to make room for one person to enter here. Okay. Now the same scenario with the linked list. Let's look at it. Here also we have a million in total. Now the same case, if I want to add this person, AAA, in position 1, what would you do now? If you have to make this person added in position 1, all I'm asking to insert this new item in position 1.
Make the previous address 234 and next address. No, make the previous address 111 and next address 234, and change the previous address of Jane to 555.
Very good. So John, the next item we want to be AAA. So here next, instead of 234 pointing to Jane, what does it point to?
555.
For Jane, the previous item is not John anymore, it is AAA. So what will be the previous address here?
555.
For this A, who will be the previous person now?
111.
And who will be next?
456.
234.
So How many changes did you do? 1,000,000?
4
Like
changes.
what you did for ArrayList? All you had to do was change in 4 places. Previous, next, previous, next, previous, next. Once you do that, you just inserted this in here. You just made room for this item in the chain. John, next person is 555. Jane, previous person is 555. So you just inserted this right in the middle of John and Jane. All we had to do was change in 4 places. The previous item, change next. The next item, change previous. They both point to the new person we are trying to add. Just 4 places. No matter how big your collection is, that's all you need. So with that in mind, if I ask you to delete Jane, how do you do that?
So next for John will be 456, and previous for Mike will be 111.
It's that easy. All you do is point to this person and point to this person, and you literally pull this out of the chain. Nobody's referring to this guy anymore. The first item is pointing to the third item now. Next is 456, this one. And the third item is pointing to the first item, 111. So this is totally out of the link now. It's as simple as that. And that's why linked list is very, very fast for editing. Okay, linked list is very fast for editing. But at the same time, it will eat up a lot of memory. See here, isn't it consuming a lot of memory? It has, every item has to remember who is next, who is previous, who is next, who is previous. Every item has to remember who is next and previous. Unlike here, you don't have to remember anything. Everything is in a consecutive block in an index. Okay, no item has to remember who is next, who is previous, nothing. They're all assigned a number and you just follow that. That's it. So when you're editing, insert or delete, this is the best choice, linked list. Okay, just one change here, you're done. No more shifting a million items. Okay, at the same time, it is very expensive memory wise. Okay, so if you have to go to, if you want to read what item you have in position 999,000, how do you do that here in linked list? First of all, do you understand the benefit of linked list?
Yes, sir.
Editing, insert or delete in the middle. When you're inserting or deleting in the middle, linked list is best. Okay, so if you want to insert in the end, which one is better?
ArrayList, I guess.
ArrayList is better. All you have to do is, current position is 1 million, so all I had to do is I had to add item in one position plus 1 million plus. Okay, so all I do is I do this. If the current position is 1 million, the new item will be inserted in 1,000,001. That's it. How do you do that in linked list if you want to add in the end of the chain? If you want to add an item in the end of the chain, how do you do that? You start from the first and check who is next. 4, 5, 6. Go to them and check who is next. Go to them, then check who is next. Okay? How long do you do this?
Until next.
Actually, find a null.
Till the very end. You do this till the very end where there is next is set to null. When you find that next is set to null, what does that mean? This is the last person, isn't it? Yes?
Yes, sir.
Then that's when you add the item here. The 1,000,001 item will be added here. You keep doing that until you reach the end of the link. At any point you find that the next is pointing to null, that is the indication that there is no one after this guy. If there is no one after this guy, meaning this is the last person. If this is the last person, then this is where you add the new item. So it's like you're reading a book, and if you want to go to page number 100, you go from 1 page, 2 page, 3 page, all the way to 100. You keep doing that. That's how linked list will do when you want to go to the end of the book. With indexes, you don't keep doing that next. You find what number you want and you directly open that page, isn't it?
Yes, sir.
Right? So if you want to go to read the end of the book, you don't go page by page till you reach the end. You just flip it on the end and there you are. So when you're inserting or deleting in the end, who is faster?
ArrayList.
Yes. Okay. Linked list is only suitable for inserting and deleting in the middle. But array list is suitable if you're just adding it or deleting from the end. This is much faster. You just add and delete here. So nobody is shifting, no shift or anything, because you are the last item. Even if you remove this item, nothing to shift. If you add a new item here, nothing to shift, faster. Only in case of inserting and deleting in the middle, linked list is helpful. Okay. If you want to read, what if I ask you to read page number 10? How do you do that in real life? You just flip it to page number 10, isn't it?
Yes.
How do ArrayList do that? You just flip or you just jump to the index number 10. How would linked list do that?
Go one by one to chart.
Yes. You say next, next, next. You keep a count on how many times you say next. If you say next, next, next 10 times, then you reach the 10th item. That's how this one does. Okay. If you want to read a 10th item for ArrayList and vector, you just jump to the index number 10. But for linked list, you might have to keep a count how many times you say next. If you say next, next, next 10 times, then yes, wherever you are right now, that is the 10th item. That's how you'd consider. So for reading items, who is better?
ArrayList.
ArrayList. Reading, insert or delete in the end, ArrayList is better. Data integrity. Okay, to avoid corruption, to avoid conflict, who is better?
Vector.
Vector. Inserting and deleting in the middle, linked list. Okay, so you guys understand how they work and what they are good at. Do you understand both the things?
Yes, sir.
All right, so that is about list. So when it comes to programming, whatever I explained you for the past 1 hour, you don't have to worry about it. The programming part is very simple. Understanding the concept is difficult. Okay, remember that. Understanding the concept is difficult. Array list, linked list, vector, they are all same. You want to add an item, just call the add method and pass the value. You want to remove, just say remove and pass the item. Okay, that's all these methods are common. Okay, whatever I'm doing add, size, get, remove, set, whatever methods I'm doing, they apply to all the three. If I change this to linked list, student collection object, I'm declaring as linked list other than array list. Are all these methods still the same? Any errors?
No.
No errors. So if you learn one thing, how to add or how to delete, you basically learn it for all the collection programs. So you don't have to go through like 10 different methods in linked list, 10 different methods in array list, 10 different in vector. You don't have to worry about that. The method names are same in all the programs, in list, set, in both. All the categories, array list, vector, linked list, everywhere, the method names are same. So you learn it once and you basically learn it for all the programs. What you need to focus on is how they are implemented, how they work internally. Okay, what is the purpose, what they are good at, that's what you need to focus on. Writing the code is simple, understanding the concept takes time. Clear?
Yes. Yes, sir.
This conference will now be recorded.
All right, so let's see how to use or declare an array, collection. Okay, first you write what you want. You want an array list or vector or linked list. Okay, write what you want. Then you tell what kind of items you want to store here. Do you want to store strings, integers, float, student objects, product objects? What do you want to store in this collection? Okay, that's what you say. This is an array list collection of string. It is a group of string object. Okay, it is a group of string object. Then you define, you write the variable name. Okay, reference variable name. We call it names. New array list and a bracket. Now this is how you declare a collection. Which collection you want to use? What is the information you want to store? Is it a string information you want to store? Group of string objects? Or do you want to store group of integer objects? Or do you want to store group of student objects? Okay, that's what you write in that anchor tag. Okay. So this is a declaration of array list collection. Is everyone clear on that?
Yes, sir.
Now let's add few items. Okay. Now since you said this names variable is going to store string in an array list. So when you say add, what can you store here?
String.
String. Okay, since you said it is a group of string object, you're only allowed to store string. Okay, you cannot say 1, 2, 3. This is an integer. Okay, so since it is a group of string object, that's what you declared. You have to store string only. Okay, so let's save 3 of them. Okay, so how many items do we have in this collection now?
3.
We have 3. Print it. You have John, Andy, and Mike. Are they in the same order that you added?
Yes.
Yes. Now, do you want to use linked list? Because you're assuming that you're going to insert and delete a lot. All you have to do is change this to linked list. It is still the same. It is still the same. All you do is declare as a linked list rather than array list. Do you want it as a vector? Declare as a vector. Print it, and you'll find all the same items. Okay. You want to remove that? Okay. You want to remove Andy? You had John, Andy, Mike, and Andy is removed. Does that mean we have any gap when we remove the middle item?
No.
They all are consecutive. Okay, just because you removed Andy doesn't mean here there will be a gap like null. Everything will be aligned. This applies to everything, vector, linked list, or anything. The same methods, add, remove. Same thing. Okay, so like I said, using is not a big deal. Writing the code is not a big deal. You just have to understand what you want from this. Okay, what you want to insert? Okay, what is the usage? Are you not expecting too much editing? Let's go with ArrayList. It is faster. If it is going to edit a lot, let's use linked list. Do you want to make sure the data is not corrupted? So 2 people try to add items or delete items, use vector, synchronized. That's all you need to decide. Once you do that, you're done. You can just go on adding and removing as you wish. The program will take care of all the things I explained you here. The program will take care of all this. How it is inserted, how it will connect, how it will delete from the middle, how it will grow in size, everything the program will take care. You don't have to worry about that. Okay. Now, list, as I explained, is indexed. List is indexed. Okay, let's go with the first one. List allows duplicate. Okay, list allows duplicate. Are there duplicates? Yes. List is indexed. Get me the item in position 2. What do I get? What's there in position 2?
Mike.
Yes. 0, 1, 2. insert Andy in position 1. So before you insert, what will be the value in this collection?
John, Mike.
John, Mike. After you insert in a specific position, index number 1, you want to insert Andy. What does it print then?
John, Andy, John, Mike.
No.
Okay, where is John? Just a minute. We are in a linked list.
This conference will now be recorded.
All right. So you can add in a particular index. You can remove from a particular index. The reason I'm stressing this is set is missing this key feature. Okay. Whatever you do, add and remove, they are supported by both list and set. But the key difference being index is missing for sets. Index is missing for sets. When you say get names.get 0, you get the first item. When you say set, you're basically editing in a specific position. Okay. When you say add, you're inserting in a specific position. When you say remove, you're removing from a specific position. So all these index-based operations that you have, they will be missing in the set collection. Okay, but rest all will be same. Yeah, let me show you here. Array list, linked list, and vector, they are all list categories. These are the set categories. Okay, so if I comment this and uncomment the set category, no problem in these lines. Here, the index method get me the index of 0. This is causing the error because set doesn't have indexes. Everything else is still the same. Addition, remove, okay, all the other how to add and how to remove, they are all same. But all the operations that are index based, insert in second position, get me the first item. Index based operations are missing in the set classes. Okay, but rest all are same no matter what you use. Okay, when you're adding, these will be supported by pretty much all the collection classes. Hash set still supports it. Okay, all right, so let's start with the first one in the set. Set has three main classes: hash set, linked hash set, and tree set. Okay, with the same example, we'll see how they are stored. So do you see any problem here or anything different than what we saw in list?
Yes.
John, Andy, Mike. Mike, John, Andy. Are they in the right order?
No.
No. So hash set is unordered. They are not ordered. Another feature, list allowed duplicates, right? You added 4, but how many are here?
3.
So no duplicates. Hash set, no duplicates. Similarly, when you use ArrayList, duplicates allowed. Okay, list allows duplicate. Set does not allow duplicates. Okay, that is the key difference. Set is unique. Now hash set, as you saw, was unordered. Let's look at the linked hash set. First of all, are there any duplicates?
No duplicate.
Is it in the order?
Yes.
John, Andy, Mike. John, Andy, Mike. Same order, no duplicates. So linked hash set has one advantage over hash set. Okay, it is ordered, not just unique, but it is ordered. Tree set. So what's happening here?
On order.
In order.
Look carefully.
Alphabetical.
Alphabetic.
Alphabetically sorted, isn't it? Andy A, John J, Mike M. It is alphabetically sorted. So no unique, first thing. Sorry, no duplicates. That is the first thing. But tree set has one more advantage. It will sort. Okay, it will also sort for you. What will it print?
ABC, Andy, John, Mike.
Yes. Tree set is sorted. So that's what this diagram is all about. If you have 5 items, John, Jane, Ram, and Raj. When you insert in array, it is in the same order. John, Jane, Ram, duplicates, and Raj. This is how it gets stored in the array. When it comes to array list and vector, they are exactly similar to array, okay, because they are implemented like an array. So they are both same, with the exception that vectors is synchronized. Look at the linked list. They are also in the same order, but how are they placed? In previous and next links, right? So they have previous and next links. Coming to hash set, you have duplicates here. Ram. In any of the set, do you see any duplicates?
No duplicate.
No duplicates. Hash set, is it in the same order that you inserted?
No.
No. Linked hash set, is it in the same order?
Yes.
Yes. How about tree set?
Alphabetical.
It is sorted. It is alphabetically sorted. Jane first, then John, then Raj, then Ram. So every collection in list and set has a unique feature that will help you to solve a specific problem. Okay. So before I show you all the methods, let's look at this. When you are deciding what you want to do, what group of, see, these are all possible ways to support group of object. Array is a group of object. ArrayList is a group of object. Tree set, map, they are all group of object. But how do you pick the right one? This map will allow you to take that decision. If you know what is the size of the group, go with array. If you don't know what is the size, what do? Go
Collection.
with collection. Okay. Now what do you want to store? A single values or a key value pair? That's what you can decide. If you want to store single, do you want duplicates or unique? If you want unique, do you want the items to be sorted? Tree set. Do you want it ordered? The way you insert, you want the same order? Linked hash set. Unordered, hash set. Okay. You want duplicates. Faster read, less memory, collection. Slower performance and multi-thread safe. This means multi-thread means synchronization. So if you want synchronization, it will have slow performance, go with vector. If you want to modify and you want good performance with that, go with linked list. So this map will help you decide if you have to select arrays or a set or a list or any specific category in each of these. Okay. Now, in comparison with list and set, who is faster? Look at what they do and then guess. In comparison with list and set, who is faster?
List.
Yes, but why? Why is list faster than the set category?
Because they're indexed.
Because
They're indexed. Like that are stored with index.
not just that. What is the one key feature of a set?
No duplicates.
No duplicates, uniqueness. How do you achieve that?
Comparing with all the data we previously had.
Yes. So doesn't that slow it down the process?
Yes.
So set is slower because it requires uniqueness check. So if you have like a million items here, okay, if you have a million item and I'm going to add 1,000,001 item here, don't you want to check if this is already existing?
Yes.
In case of array list or vector, any list category, you just insert that in the end and you're done. But in case of set, you have to compare. If this value exists here, 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 you have to check it in all the position and then decide if it is unique. And if it is unique, then it will get added. So doesn't that make it slower, comparing and then deciding whether to add or not?
Yes.
That's why set is slower. Okay, set is slower than list, but it gives you that uniqueness quality. Okay, it gives you uniqueness, it gives you sorted functionality. So there are a lot of good things on what exactly set can do. Okay. All right, so we'll see all the methods in list and set, and we'll do map in the next class. Okay. So here, what I did was I listed all the classes that we have in list: ArrayList, linked list, vector. and then hash set, linked hash set, tree set. So the 3 programs in each categories, list and set. Okay, I'm declaring all those things. So you can just uncomment and see what are the methods. If you want to test vector, just uncomment and run the program, and it will show you how it adds and removes and everything. Okay, regarding how set provides this uniqueness feature, how does it check the uniqueness, I will explain you that in the next class. Okay, because that is part of the map logic. Okay, how set is implemented internally. To learn that, you need to know what a map is first. If you know how map works, you will also understand how a set works. Okay, all right. So be it any class, linked list, vector, hash set, be it any program, add method is supported by everyone. You say add, and this new value gets inserted in the collection, then the next and the next. Okay, in case of vector, does it allow duplicate? Vector belongs to list or set?
List.
List. So are list unique?
No.
No. So this will basically give you how many items? The size?
4.
4, because vector allows duplicate. Okay, now there is a method on, if you want to know what is the size of your collection, there is a method called size. Okay, so do you guys recall what is that you say in arrays to get the size? Is there a size method in array to get the size?
Not length.
Length. Okay, there is a length, not a size. In array, if you want to know what is the size of an array, you say length. In collection, we say size. Okay, so when you say size of this object, student collection, it will say 4. We have 1, 2, 3, 4. We have 4 items. So the size will give you 4. Now, student collection dot get me the item from index number 0. So what do you get here? What value do you get in here?
Ram.
RAM. Okay, so on the right hand side, when you say student collection dot get me the item from index 0, in student collection the first item at index 0 was RAM. So that value from right hand side goes to this variable. Okay, so when you print that first student variable, what does it print?
Ram.
RAM. Okay, now here is a slight difference. If I declare this object student collection as a hash set, not as a list category, but as a set category, this will not work. Get me the 0 item, this will not work. And the reason is sets are not
Support index.
not indexed. Sets doesn't have index, and that's why you cannot get an item by index. Okay, same applies to this thing as well. Set in the position 2, I want the value Bharat. In position 2, in index 2, I want the value Bharat. Since this is a hash set, it does not support this. Index based insertion, it doesn't support that. Okay, what you need to do, you need one of the list category, array list, linked list, or vector. And this one supports it because this variable is now declared as linked list. Okay, again, add method, as you saw earlier, is a overloaded polymorphism. What is the difference in these two? If you do not give an index, where does it insert?
Last.
Last, in the end. If you give an index, where does it insert?
One index.
In that position. Remember, okay? Add method is overloaded. There is a polymorphism in the add method. So you can add in the end of the collection or in a specific location. So to do that, can I declare this variable as tree set?
No.
You cannot, okay? Because tree set does not support indexes. Anything to do with index, any set will not support. Hash set, tree set, none of them will support it. Okay, because set is not indexed. All right. So set basically overwrites the item in position 2, whereas add will insert. Okay, so this, the difference between this and this is set is basically overwriting. It overwrites whatever you have in position 2. In this case, 0, 1, 2. So this entry will be overwritten by Bharat. Okay, that's what set does. Whereas add will insert. It doesn't overwrite, it will insert in the middle, and everything gets shifted by one line, one step below. Okay, that's the only difference between these two. But they both are meant for index-based changes. Now, this one is the reverse of get. You pass the index and you get the value at that index. Okay, in this case, you pass the value and get the index in return. So when I pass Ram, what index do I get?
0.
First item, 0. Okay, first item, 0. So it's a reverse of the get by index. All right, here, remove 0, meaning remove the item from 0 position. So what will it remove?
Ram.
Ram. Either you can remove by index or you can remove by value. Okay, so you can say I want to remove the item from index number 1, or you can say I want to remove the value, the record which has value as Ram. So you can delete by the value or delete by index. Okay, so again there is a polymorphism here. Same method name, different input. This takes integer, this takes string. Polymorphism here. You can, the goal is same, removing items from the collection. How you do that is different. You do that by indexes or by values. Polymorphism right here. All right, I'll get to iterator in a minute. This is what we call enhanced for loop or for each. Okay. Now instead of doing all the initialization, condition check, increment, all the traditional way to read an array, we don't need that with for each. Okay, so this is how you use this for loop. All right. Here, all you need is two parts. What is the collection name? It is students collection. Now, what data type do we store in this collection?
String.
We store string. So all you do is declare a variable, string, whatever you want, A, B, C, D, S, whatever you want. Okay, declare a variable that this collection stores. String S, string A, whatever. Then this, look carefully, this is not a semicolon, this is a colon. Okay, so declare a variable that is the same data type as the collection. So this collection data type is string. So declare a variable that is also string, followed by colon, and on the right hand side, give the collection's name, student collection. That's it. No more initialization, condition check, declaration, blocks, I, 0, 1, nothing. Just declare like this, and this loop will go one item after another, increment one after another, and get you the values. This is the enhanced for loop, or for each. Okay, very simple to read items, just like an array, but slightly advanced. Now, one thing you need to remember is this is not suitable for editing. For each is only suitable for reading collections. If you want to read the items of the collection, if you want to see what are the values in this collection, you can use this. But if you want to edit, this will give you an error. Okay, for will give you an error if you are editing the collection. If you're just reading, it is faster, it is better. Okay, so for editing, we have one more thing called iterator. Okay, we have one more thing called iterator for editing. All right, so let's see how the iterator works. Now, iterator is more like a cursor. Okay, iterator is more like a cursor, a pointer. So you have John, Jane, Mike, Andy, and so on. Okay. Right, so this is your code. So let's see how the iterator works. Okay, so this is your collection, students collection, and you want to read all the items inside this or edit. Okay, so you can use it for both editing and reading. Okay, so let's see how the iterator works. Here, first you say, I want to get the iterator. So there is a method in all the collection classes called .iterator. Okay, so when you do that, you get an iterator object in return. Okay, so since this collection is of type string, the iterator is also of type string, so you can read through a string values. Okay, that's what it means. All right, so when you say .iterator, this is what you get. It's like a cursor. Okay, it's like a pointer, a cursor. So this cursor will be placed on top of your collection like this. Okay, this cursor will be placed on top of your collection. Okay, so once you get the iterator, that is the pointer or cursor, the first thing you ask is, in this iterator, do we have any more items? Has next meaning you're checking. You are checking if there are any more items to read in this collection. So right now your cursor is pointing here. Do you have any items to read?
Yes, right, sir.
Yes. So this will return you true. Okay. So once it returns you true, you enter the loop and you say, get me the next item. So that will do two things. The cursor will move here and it will give you the value John. So in the first loop, the value John gets assigned to the student name variable, okay, which you then print. After that, you go back to the condition and you say, do we still have any more items? Has next. Cursor is pointing here. Do we have few more items to read?
Yes.
Yes. Okay, so let's move it here. Say next, and it will give you the Jane value in the second loop. It keeps on doing that until you reach the end. Okay, so right now cursor is pointing here. Now here, when you say has next, is there any more items next?
No.
No. When there are no more items to read, this method has next will return you false. So when it returns false, this condition breaks and you come out. Okay, so that's how the iterator operates. Okay, you need to get a cursor so you can read it. So you can read the collection, okay, by calling the method student collection dot iterator. This method will return you a cursor like thing called iterator. Now using this iterator object, you do a check, has next. If there are any more items, let me know, true or false. If yes, true, there are few more items to read, then I will move my cursor and fetch that value. Okay, so you keep doing that until the cursor reaches the end. When there are no more items to read, this condition will fail. Okay, so that's how the iterator operates. So for reading the collection, you can use either one of them, iterator or for each. For editing, use iterators only. Okay. Now the for loop and the iterator, they are supported by both of them, set and list. Okay. Only thing that is not supported by set and list is your index based calls. Okay. So when you declare a set, everything is fine except index operations. Insert in index 1 cannot. Get me the item from index 0 cannot. Remove from item 0 cannot. Set in item in index 0 you cannot. The only problem with set classes is anything index based. But other than that, you can declare the program, you can declare any collection and all these methods will work just fine. Getting the size, reading the items, removing items, getting the index, adding items. Okay, you can declare any collection you want and they will be supported by all the methods. Okay, so I want you guys to practice this conceptual part, because as you see, it is not really a big deal with the methods. Okay, there are barely like 3 or 4 methods: add, remove, set. Okay, there are barely 3 or 4 methods to memorize. The difficult part is choosing the right one. Which one do you want to pick for your project? ArrayList, linked list, vector, tree set? That will be the tough part, to understand the concept. Once you understand the concept, then you can make the right decision. Okay, so focus on that part. Understand how they work and what are their unique qualities. Okay, remember their unique qualities. What is it that it is well known for? Okay, remember their qualities, remember their unique features, and then you'll be able to decide on which one to pick. But when it comes to practicing the writing the code, it is quite simple. If you remember all these methods, add, remove, set, get, if you remember these methods, that's it. You can apply that to any collection that you want. They all support the same methods. Okay.